Introduction. Today's morning is very good.
Yes, Dad. It is a sunny day.
So, how is your study going?
The study is going very good, Dad.
Excellent, Aryan.
Dad, I want to ask you something.
Yes, dear.
Dad, all these vehicles such as cars, trucks, etc. run on fuel.
Yes.
Does the space shuttle also run on the same fuel?
My son, a special type of fuel is used in space shuttle.
What kind of special fuel, Dad?
They use hydrogen in the external tank to lift off the space shuttle. Would you like to learn more of it?
Yes, Dad.
In this lesson, you will learn hydrogen and its compound. Objectives. At the end of this lesson, you will be able to locate the hydrogen in the periodic table and define the isotopes of hydrogen. Explain the preparation of dihydrogen, physical and chemical properties of dihydrogen. Explain hydrides. Position of hydrogen in the periodic table. Hydrogen is the first element of the periodic table with atomic number 1. As it has only one electron, so its electronic configuration is 1s1. Because of the dual behavior of hydrogen, it is quite difficult to find a proper place in periodic table as it has resemblance with alkali metals and with the halogens. Like alkali metals, it has only one electron in its valence shell. Like halogens, hydrogen is short only by one electron to complete the inert gas configuration. Dihydrogen, H2. Occurrence. Dihydrogen is the most spontaneous element in the universe. It has about 70% of the universe's total mass. Jupiter and Saturn mostly consist of hydrogen. Half of the mass of the Sun and some other stars made up of hydrogen. In the combined form, it forms 15.4% of the Earth's crust and oceans. Earth does not have enough gravitational pull to retain the light hydrogen molecule, so it is not found in our atmosphere. Isotopes of hydrogen. Hydrogen has 3 isotopes. Protium. Its atomic number is 1 and mass number is also 1. It has 1 proton but no neutron in its nucleus and 1 electron in its 1s orbital. It is represented by symbol H. Its abundance is 99.985%. Deuterium. Its atomic number is 1 and mass number is 2. It has 1 proton and 1 neutron in its nucleus and 1 electron in its 1s orbital. It is represented by symbol D. Its abundance is 0.0156%. Tritium. Its nucleus has 1 proton and 2 neutrons and there is 1 electron in its 1s orbital. It is an extremely rare isotope. Out of 10 to the power 18 molecules of ordinary hydrogen, there is just 1 molecule of tritium. This isotope of hydrogen is radioactive in nature and emits low-energy beta particles. Its abundance is 10 raised to the power minus 15%. Preparation of dihydrogen, H2. Laboratory preparation of dihydrogen. In the laboratory, hydrogen is generally prepared by the action of dilute mineral acids on metals such as granulated zinc. Few pieces of granulated zinc are placed in Bohr's bottle, which is fitted with a thistle funnel and a delivery tube. Dilute sulfuric acid is poured through thistle funnel. The acid reacts with zinc, evolving hydrogen, which is collected in jar by downward displacement of water. Pure zinc is not used as it is non-porous and therefore, after some time, the reaction slows down. Hence, granulated zinc is used that is impure and it increases the rate of reaction. Commercial production of dihydrogen. Electrolysis of water. It involves the electrolysis of acidified or alkaline water. We use dilute H2SO4 to make water acidified. Dilute sulfuric acid is enough to make water act as an electrolyte. When anode and cathode are connected to a battery, it produces a small amount of current of the order of few milliamperes and bubbles start appearing in the two arms of the voltmeter. The anode collects oxygen and the cathode arm collects hydrogen gas. The reactions taking place are dissociation of H2SO4. H2SO4 gives 2H plus SO4 2 minus. Dissociation of H2O. H2O gives H plus OH minus. Reaction at cathode. H plus electron gives H. H plus H gives H2. Reaction at anode. OH minus gives OH plus electron. 4OH gives H2O plus O2. Overall reaction. 2H2O gives 2H2 plus O2. At the anode, OH minus ions are released in preference to SO4 2 minus ions. This is because it is easier for an OH minus ion to give up an electron quickly than for the SO4 2 minus ion to do so. Since the sulfuric acid itself does not participate in the chemical reaction that is taking place, it can be called as a catalyst of the reaction. Commercial production of dihydrogen. Dihydrogen can be prepared by the action of steam with red-hot coke as given below. The water gas formed is also called synthesis gas or syngas. Then water gas is mixed with steam and is passed over heated Fe2O3 and Cr2O3 at 770 Kelvin. Then CO is oxidized to CO2. Gaseous mixture of CO2 and H2 is then bubbled into cold water under pressure when CO2 dissolves, leaving behind dihydrogen gas which escapes out. This reaction is called water-gas shift reaction. Properties of dihydrogen. Physical properties. It is colorless, odorless, tasteless gas. It is lighter than air and collected by downward displacement of water because it is insoluble in water. It is highly combustible. It is the lightest of all elements. Chemical properties of dihydrogen. Reaction with halogens. The reactivity of halogens with hydrogen is fluorine greater than chlorine, greater than bromine, greater than iodine. Hydrogen reacts with halogens to give hydrogen halides. Reaction with dioxygen. Hydrogen reacts with dioxygen to give water. Chemical properties of dihydrogen. Reaction with dinitrogen. Hydrogen reacts with dinitrogen to give ammonia. Reaction with metals. Hydrogen reacts with metals to form hydrides, where M is an alkali metal. For example, 2Na plus H2 on temperature 525 Kelvin gives 2NaH. Chemical properties of dihydrogen. Reaction with metal ions and metal oxides. Hydrogen reacts with metal ions and metal oxides to give corresponding metal. For example, reactions with organic compounds. When hydrogen is passed through edible vegetable oils at about 473 Kelvin in presence of finely divided nickel as a catalyst, they undergo hardening and change into edible fat. Uses of dihydrogen. It is used in synthesis of ammonia. Nitrogen and hydrogen passed to heater, where these are heated up to a certain temperature. After that, they are compressed and then passed to heater, where the reaction takes place. After that, the mixture is passed to waste heat boiler, from which ammonia is cooled and then stored, and nitrogen and hydrogen are recycled. It is used in the manufacture of vanaspati ghee. It is used as a rocket fuel in space research. It is used in fuel cells for generating electrical energy. Hydrides. Hydrides are referred to binary compounds that hydrogen forms with other elements of the periodic table except noble gases. Hydrides can be categorized as ionic or saline hydrides. The ionic hydride form between hydrogen and the most active metals, especially with the alkali and alkaline earth metals of group 1 and 2 elements. In this group, the hydrogen acts as the hydride ion. They bond with more electropositive metal atoms. Electrolysis of solution of saline hydride in molten alkali halide produces H2 at anode. The reaction is given as. Alkali metal hydrides are also used for the removal of last traces of water from organic compounds. Covalent or molecular hydrides. Hydrogen form molecular compounds with p-block elements. Common examples of such hydrides are CH4, NH3, H2O, HF, etc. The stability of these hydrides decreases down the group. For example, in a period, the stability increases with increasing electronegativity. For example, covalent or molecular hydrides. Molecular hydrides are classified as electron-rich molecular hydride. These hydrides have one or more lone pairs of electrons around the central more electronegative element. For example, water has 2 lone pairs. Electron-precise molecular hydride. These hydrides have required number of electrons for Lewis structure. A common example of electron-precise molecular hydride is methane. Electron-deficient molecular hydride. These hydrides have lesser number of electrons than that required for Lewis structure. A common example of such molecular hydride is diborate. Metallic or non-stoichiometric or interstitial hydrides. These hydrides are generally formed by the transition metal of group 3, 4, 5 of D- block, Cr metal of group 6, F- block metals. The elements of group 7, 8, 9 of D- block do not form hydrides at all. This inability of metal of group 7, 8, 9 of periodic table to form hydrides is referred to as hydride gap of D- block. In these compounds, H atoms occupy interstitial positions in the metal lattices. For example, SCH2, LaH2.87. Did you know? Boeing unveils new hydrogen-powered aircraft. Boeing has been working to make new aircraft more environmentally friendly. Boeing and others have been developing new aircraft that make use of alternative energy. Further tests with the aircraft will help Boeing understand the best use for the fuel cell and the other technologies it has chosen for the plane.
Summary.
Let us summarize what we have learned. Hydrogen is the first element of the periodic table with atomic number 1. 3 isotopes of hydrogen are protium, deuterium and tritium. In laboratory, Dihydrogen is prepared by the treatment of zinc granules with dilute sulfuric acid. Hydrogen is colorless, odorless, tasteless gas and highly combustible gas. Hydrogen reacts with halogens to give hydrogen halides. Hydrogen reacts with dioxygen to give water. Hydrogen reacts with dinitrogen to give ammonia. Hydrogen reacts with metals to form hydrides. Hydrogen reacts with metal ions and metal oxides to give corresponding metal. Hydrides can be categorized as ionic, covalent and metallic hydrides.